Hello and welcome to Manifest Maths. This continues our series on coordinate geometry. Today we're going to look at points of intersection. We're going to look at typical past paper questions. We're going to come back to this question at the end and you're going to give it a try. You see here that we are looking for today points where two lines intersect. So this combines all the skills that we've gone through in the coordinate geometry series. Let's go straight into a question. We've got 4 points, A, B, C and D. We've got to find the gradient of AC first of all. So for part A, the gradient of AC, so if we call A our x1 and our y1 and C our x2 and our y2, we're going to find the gradient first. So our gradient is equal to change in y divided by change in x. So 4 minus 16 over minus 6 minus 3. 4 minus 16 is minus 12. And minus 6 minus 3 gives us minus 9. Negatives will cancel to give us a positive. They can both be divided by 3, which gives us a gradient of 4/3. That was part 1. Part 2 showed the equation of AC is 4x minus 3y plus 36. So we're going to use the equation of a straight line, which is y minus y1 equals m brackets x minus x1. We're going to substitute in our a values as our x1 and y1. We could use either. So y minus 4 equals our gradient, which is 4/3, brackets x minus 6. That gives us y minus 4 equals 4/3 x plus 6. Now to deal with the 3 at the bottom here, we're going to multiply the left hand side by 3, which gives us 3y minus 12 equals, I'm going to expand the brackets at the same time, so 4 times by x is 4x, 4 times by 6 is plus 24. Then we're going to take everything to the right hand side, leaving nothing on the left. The 4x is going to stay there and be positive. We bring the 3y over, which becomes minus 3y, and then add the 12 onto 24, which gives us 36, which is what we needed. Part 3. Show that the equation, show that BD is perpendicular to AC. So what we've got to find here is the gradient of BD. So now we're going to give B our x1 and y1, and D our x2 y2, and then find the gradient. So we're going to have minus 1 minus 11 over our x1 minus y1, which is 9 minus 7. That's going to give us minus 12 over 16, which gives us, and they can both be divided by 4, which gives us minus 3 over 4. Now, to show that they're perpendicular, you will say that m1, which is our first gradient, times by the gradient of BD needs to equal minus 1. So 4/3 times by minus 3 over 4, which gives us minus 1. So we've shown they're perpendicular. Part 4. Find the equation of BD. So now we're going to use the equation of a straight line again. Y minus y1 equals, this time, our new gradient, x minus x1. We're going to use our b values for our y1 and x1. So we have y minus 1 equals minus 3 over 4, x minus 9, which gives us y plus 1 equals minus 3 over 4, x minus 9. Now we're going to multiply both sides by 4, which gives us 4y plus 4 equals minus 3x plus 27. And I'm going to take everything to the left hand side, so 0 equals minus 3x minus 4y, and if you take the 4 off 27 plus 23. That's our second equation. So next part of the question, which is part B, which I'll do up here, asks us to find the point of intersection, which is E. So what we have is two simultaneous equations. The first one being 0 equals 4x minus 3y plus 36. And the second one being 0 equals minus 3x minus 4y plus 23. So step 1 is to try and get the y coefficients equal. So I'm going to times the top equation by 4 and the bottom equation by 3. That gives us two new equations, both with 0 on the left. Times the top equation by 4, that gives you 16x minus 12y plus 144. Times the second equation by 3, that gives you minus 9x minus 12y plus 69. We're then going to subtract the two equations because we've got minus 12y for both. 16x minus 9x gives us 25x. These two terms will cancel. 144 minus 69 gives us 75. Bring the 75 over to make minus 75 equals 25x. And then minus 75 divided by 25 gives you x equals minus 3, which you can see is what we needed to get. So I'm going to come down here. Then to solve for y, you could use the first equation. So 0 equals 4x minus 3y plus 36. Substitute x equals 3n. So 0 equals 4 times minus 3, which is minus 12, minus 3y plus 36. So 0 equals minus 3y plus 24. Bring the 24 over, so minus 24 equals minus 3y. Then divide minus 3 into minus 24, which gives you y equals 8. And we've proven the second point. Okay, so this is one for you to try, so pause the video and give this one a try. Okay, so here's the solution for this question. First step is to find the gradient AB, and then find the perpendicular gradient, which is a half. Then substitute this gradient of a half into your equation of a straight line using B as your coordinates. That simplifies to 0 equals x minus 2y minus 11. Then the next step was to solve the simultaneous equations, with the second equation being the one you were given. Now we'll notice that this first simultaneous equation, we had 1x, so I've opted to make the x coefficients the same by timing the top equation by 6. Okay, few potential mistakes here. We're going to eliminate the x's first, so 6x equals 6x will cancel, then 7 minus 12y will give you 19y, and 10 minus 66 will give you 76. And that's solved quite easily to give you minus 4. Then substitute minus 4 into the first equation. Just be careful there, look, minus 2 times minus 4 will give you the plus 8. And then follow the question through, which gives you the two coordinates that you need. Okay, right then. Here's 3 questions for you to try, and the answers will be on the next 3 slides. So pause the video and give these questions a try. Okay, so here's a solution for the first question. The gradient of AB was minus 2, and the gradient of CD was minus 2. So the lines were parallel. The equation of AB, substitute your values for A or B in. I opted to use the coordinates for A, using minus 2 as your gradient. That gives you the following equation: y plus 2x minus 4 equals 0. Then it tells you that line L is perpendicular to AB, so therefore the gradient of L was a half. Substitute half in and use your coordinates for D. Simplify, and that gave you this equation, which is the one you were trying to show. Then to solve them simultaneously, write the two equations out, times the second one by 2 to get the x coefficients the same. Subtract the two equations, again being careful with the negatives. Y minus 4y gives you 5y. Minus 4 minus 26 gives you minus 30. That gives you a y solution of 6. Then substitute into the original equation and rearrange, and that gives you an answer of minus 1 for x. So here's the solution for this question. Step 1 was to find the equation of AB, which is to find the gradient first, which was 2. Then substitute the gradient in the equation of a straight line, simplify, that gives you the answer 0 equals 2x minus y minus 7. Part B, you have to show the lines were perpendicular. Now to do so, I would have written the equation of straight line L out, then made y the subject. So if you bring the x over to minus x and the 11 over to plus 11, then if you divide both sides by 2, that gives you y equals a half x plus 5.5. So that means that the gradient of L was a half. And then you're going to show that the product of the two gradients was equal to minus 1. So 2 times by minus a half equals minus 1. So therefore the lines are perpendicular. For part C, write the two equations of the line out. Again, I would have multiplied the second one by 2 to scale the x's up. So you had 2x for both. Subtract the equations. Minus y minus 4y gives you minus 5y. Minus 7 minus 22 becomes minus 7 plus 22, which gives you plus 15. Then bring the 15 over to the left. Keep the 5y on the right. Divide minus 15 by minus 5, which gives you y is 3. Then the last step was to substitute in to solve for x, and as you can see, you end up with x equals 5, giving you the coordinates 5, 3. Okay, and the third question. Okay, so here's the solution for the third question. Step 1, find the gradient of AB. That gave you minus 3 over 2. Now it tells you that L1 is perpendicular to AB, so therefore the gradient of L is the negative reciprocal, which is 2/3. Now this is the gradient you had to use, but you also had to use point B because it tells you that L1 or L goes through B. So to use the 4 on the 1 and the gradient 2/3, and then simplify by bringing the 3 up, times in the y and the minus 1 by 3, which give you 3y minus 3. Then take everything to the right hand side, which give you the following equation. Part B is to solve the simultaneous equations to find the point of intersection. This was the equation you just found, and this is the one that you were given. So double the second equation, the one you were given, which gave you 2x minus 16y minus 144. Then subtract the two equations, giving you 13y plus 39, and that allowed you to make y as minus 3. Then substitute into the first equation, which gave you x as minus 2. Okay, so let's return back to the question that was on the first slide. Okay, and I'm going to give you a chance to try this one. This is from a recent past paper. So I'm going to work through this one at the same time. So we've got 3 points A, B and C with respective coordinates. L1 passes through the point A and is parallel to BC. The line L2 passes through the point C and is perpendicular to BC. So step 1, find the gradient of BC. So we're going to start off by leading you through this question. So the gradient of BC will be equal to the change in y divided by change in x, and we're going to use B and C. So 12 minus 8 over minus 5 minus 3 gives you 4 over minus 8, which is minus a half. Part B. Show that L1 has the following equation. Now L1 passes through point A and is parallel to BC. Because it's parallel, it's got the same gradient. So the equation of L1 is going to be y minus y1 equals m brackets x minus x1. It goes through point A, so we have to use the coordinates of point A. So it's going to be y minus 10 equals, we can use the same gradient because it tells us it's parallel, minus a half x minus 11. deal with the fraction first by multiplying the second left-hand side by 2. So 2y minus 20 equals minus x. The minus here makes plus 11, but then we've got a minus outside, which will take us back to minus 11. It wants us to bring everything to the left-hand side. So if you bring the x over, it makes minus x over, makes plus x. We've already got a positive 2y there. And then if we add 11 on to minus 20, that gives us minus 9. And that's our first part. And you can see it matches this equation. So for part 2 of B, we have to find the equation of L2. Let's go back and read the conditions for L2. It passes through point C and is perpendicular to BC. So for this one, to find the gradient of L2, we must find the perpendicular gradient. So we take the reciprocal of minus a half and make it positive, so the gradient is 2. Then we're going to find the equation of the line. So y minus y1 equals m bracket x minus x1. And it tells us it goes through C, so we've got to use coordinate C. So y minus 8 equals 2 brackets x minus 3, which gives us y minus 8 equals 2x minus 6. Let's take everything to the right hand side here, which gives us 0 equals 2x minus y. If we add the 8 onto minus 6, it gives us plus 2. Okay, so that was part 2. And then part C, we have to show where these lines intersect. So we're going to write the two equations out. The first one was 0 equals x plus 2y minus 9. And the second one we found was 0 equals 2x minus y plus 2. Now, we could make the y coefficients or the x coefficients the same. I'm going to times the top equation by 2. So we have 0 equals 2x plus 4y minus 18. And 0 equals 2x minus y plus 2. We've got the x coefficients the same, so we can subtract 4y, well, 2x, take away 2x, they'll cancel. 4y minus 1y becomes 4y plus 1y. So that gives us 5y. And minus 18 plus 2 gives us an answer of minus 16. Sorry, I've just noticed my mistake. This won't be minus 16. Minus 18 minus 2 gives you minus 20. And then bring the 20 over, so it becomes positive. And then divide 20 by 5, which gives you y is 4, which is what we needed. Solve for x, so 0 equals x plus 2y minus 9. 0 equals x, 2 times by 4 plus 8 minus 9. So 0 equals x minus 1. So 1 equals x. And then we've got the correct set of coordinates. Okay. Right, the last video in the series for coordinate geometry is going to be on full particle questions. Alright. So we've done individual parts now, building up from finding gradient, midpoints and so on, all the way up to points of intersection. So the last video is going to summarize all of these. Okay. So I do hope that you use the last video for your revision.